This video will go over graphing quadratics in standard form. The standard form for a quadratic is y equals ax squared plus bx plus c. If you look at number 1, the a value is the number in front of x squared. So in this case, a is 1. B is the number in front of x, so b is negative 2. And c is your constant, or your number alone. So in this case, c is negative 3. In order to graph these, we're going to first make a table. And to find the center of your table, you're going to use your axis of symmetry formula. This formula is opposite b over 2a. So using the numbers that we just found, 1, negative 2, and negative 3, I am going to plug those in. The opposite of negative 2 is going to be positive 2, and then I'm going to plug in 1 for a. This means I have positive 2 over 2, so my axis of symmetry is at x equals 1. This is where you're going to center your table. It's also the x value from your vertex. This tells us that we are going to center our table around 1, so I'm going to go away from it by using 2 and 3, and the other direction I'll use 0 and negative 1. Now to fill in our table, we're going to use our function, so in this case it's x squared minus 2x minus 3, and we're going to plug in our x values. So starting by plugging in negative 1, I have negative 1 squared minus 2 times negative 1 minus 3. This comes out to positive 1 plus 2 minus 3, and 3 minus 3 means this value is at 0. Same thing with 0. I have 0 squared minus 2 times 0 minus 3. Well, 0 minus 3 gives me negative 3 here. Plugging in 1, I have 1 squared minus 2 times 1 minus 3, which is 1 minus 2 minus 3. This simplifies to negative 1 minus 3, which is negative 4. Plugging in 2, I get 2 squared minus 2 times 2 minus 3. Well, 4 minus 4 minus 3 comes out to negative 3, which it should because your table should be symmetric around your vertex, around your axis of symmetry. So finally, double checking with 3. 3 squared minus 2 times 3 minus 3 is 9 minus 6 minus 3, which goes to 0. Now that I have my table, I'm going to plot these points. So I have 1, negative 4. I have 2, negative 3. 0, negative 3. 3, 0. And negative 1, 0. If you wanted to keep going, you could. I could plug in 4. Plugging in 4 gives us 16 minus 8 minus 3, which actually will fit on my graph, so 4, 5, which means I'll also have negative 2, 5, because our quadratics are always going to be symmetric. I want you to pause the video, try to fill in the missing vocabulary, and then restart when you're ready to check. For your vertex, you should have gotten the point 1, negative 4. This is a minimum. The x-intercepts here, I'm crossing at 3, 0, and at negative 1, 0. I have 2. My y-intercept is at 0, negative 3. It goes left and right forever, so my domain is all real numbers. And my range starts at negative 4 and moves up forever, meaning y is greater than or equal to -4. Let's move on to number 2. First, I need to name A, B, and C. So for this problem, A is 1, B is -2, and C is 8. When I plug this in to my axis of symmetry formula, opposite B over 2A, I have the opposite of -2 over 2 times 1. This simplifies to 2 over 2, so my axis of symmetry is at x equals 1. This is where I'm going to center my table. Now, to find my y values, I'm going to use the same x values as before, and I'm going to plug these in to my equation, x squared minus 2x plus 8. For -1, I have -1 squared minus 2 times -1 plus 8. 1 plus 2 plus 8 comes out to be 11. For 0, I have 0 squared minus 2 times 0 plus 8. 0 minus 0 plus 8 is just 8. 1 squared minus 2 times 1 plus 8 would be 1 minus 2 plus 8. And -1 plus 8 is 7. Plugging in 2, I have 2 squared minus 2 times 2 plus 8, which simplifies to 8. And then finally plugging in 3 squared minus 2 times 3 plus 8 is 9 minus 6 plus 8, which gives us 11. So now that I have my points, I'm going to plot them. And I have 1, 7, 2, 8, and 0, 8. That's all that will fit on my graph. Go ahead and pause the video, fill in the missing vocabulary, and then check with me. Your vertex on this one is 1, 7. It is a minimum. For your x-intercepts, it never crosses the x-axis, so there are none. Your y-intercept happens where it's crossing the y-axis, so in this case, it's at 0, 8. Your domain, we go left and right forever, so all real numbers. And then I'm starting at 7, going up forever, so y is greater than or equal to 7. Moving on to number 4. On number 4, my a value is 2, my b value is -12, and my c value is 16. Plugging this into my axis of symmetry formula, I get 12 over 2 times 2. This simplifies to 12 over 4, which is 3. So my axis of symmetry is x equals 3, and I'm going to center my table around 3. So 2 away from it on both sides, I'm going to use 4, 5, 2, and 1. Plugging these numbers in, I have 2 times 1 squared minus 12 times 1 plus 16. This simplifies to 2 minus 12 plus 16, which ends up giving us 1/6. For +2, I'm going to plug 2 in for both of my x's. And we end up getting 8 minus 24 plus 16, which is -16 plus 16, which is 0. Plugging in 3, I get 18 minus 36 plus 16. So this would be negative 18 plus 16, which is negative 2. Plugging in 4, I get 2 times 16, which is 32, minus 48 plus 16, which is negative 16 plus 16, which is 0. You'll notice that your table is symmetric around your vertex, around your axis of symmetry. So by looking at the pattern, when x is 5, your y has to be 6 because it has to stay symmetric. Now I can plot these points. I have 3, negative 2. I have 2, 0. I have 4, 0. I have 1, 6. And I have 5, 6. Go ahead and pause the video, try to fill in the missing vocab, and then check with me once you're ready. All right, your vertex should be the 3, negative 2. This is a minimum. My x-intercepts, I'm crossing the x-axis at 2 and at 4. So I have 2, 0, and I have 4, 0. Now, you can't see your y-intercept on the graph. So when that happens, you have to plug in 0 for x. That means that it's just higher, so where we can't see it. So if I plug in 0 here, 2 times 0 is 0. 12 times 0 is 0. So I am left with positive 16. My y-intercept here is 0, 16. Remember, your y-intercept always happens when x is 0. My domain is all real numbers. And then I'm starting at negative 2 and moving up forever. So y is greater than or equal to negative 2. For our last problem, you'll notice that I need to move the 6 over before I begin. So in order to start, I have to add 6, and I'm actually graphing x squared minus 4x plus 6. My a value here is 1, the number in front of x squared. My b value is negative 4, and my constant, or my c value, is 6. I want you to pause the video, try to graph this one completely on your own, and then check with me once you're finished. When you use the axis of symmetry formula on this problem, opposite b over 2a would be the opposite of negative 4 over 2 times 1. This comes out to 4 over 2, which means my axis of symmetry is at x equals 2. I'm going to fill in my x values away from 2, and I'm going to plug these in to figure out my y values. So plugging in 0, I have 0 squared minus 4 times 0 plus 6. 0 minus 0 plus 6 means I have the point 0.06. Plugging in 1, I have 1 squared minus 4 plus 6. Negative 3 plus 6 is 3. Plugging in 2, I have 4 minus 8 plus 6, which ends up giving me positive 2. Plugging in 3, I have 9 minus 12 plus 6, which also gives me positive 3, which is good because this should be symmetric. So when x is 4, my y will be 6. If we go ahead and graph this, I have the point 2, 2. I have 1, 3. I have 3, 3, 0, 6, and 4, 6. My vertex here is 2, 2. It is a minimum. I'm not crossing the x-axis at all, so my x-intercept would be none. My y-intercept, I am crossing right here at 0, 6. My domain would be all real numbers. And I'm starting at 2, going up forever. So my range is y is greater than or equal to 2. Before we pause this video, I want to take a moment to show you what this would look like on your calculator. So for today, we didn't have a calculator, so we had to plug all of these in by hand. When you do have a calculator, it will do all of that work for you. So I'm going to show you how to graph number 4 using your Inspire. So on the calculator section of your test, I would go to your graphing scratchpad. So remember, if you start on the home screen, hit the scratchpad button until you get to the graph. I'm going to type in my equation, so x squared minus 4x plus 6, and then I'm going to hit enter. So you can tell by looking at the graph that we did this correctly, but to check your points more precisely, you can hit Control T. If you look at this table, it actually does match the table that we made by hand. I have the point 0, 6, 1, 3, 2, 2, 3, 3, and so on. So if you ever need to graph this in your calculator, you just enter it in and then hit Control T. Control T will give you the table so you can check. If you ever need to clear your screen quickly, Dock B will clear it and take you back to normal. You need to know how to graph these both by hand and in the calculator. So remember, with standard form, you need to have your axis of symmetry formula memorized, opposite b over 2a, and you need to know that a is the number in front of x squared, b is the number in front of x, and c is your constant. Don't forget to keep these vocabulary words fresh for all types of quadratics.